There is a moment in science when the data comes back and the room goes quiet, not because nothing happened, because something happened that nobody can explain. That moment came for NASA's James Webb Space Telescope team in the early hours of an ordinary morning. The numbers on the screen were clean. The instrument was working perfectly. The signal was real and verified and cross-checked 3 times over. And it showed something that every cosmological model we have built over the past century said was flat out impossible. Not unlikely, not surprising, impossible. Galaxies that should not be fully formed. Structures that should not exist at that point in cosmic time, existing. Light from the edge of the observable universe carrying information that forced scientists to stop and ask a question nobody wanted to ask out loud. What if we have been wrong? Not wrong about one small detail, not wrong about one variable in one equation, wrong about the fundamental story of how the universe was born, grew, and became what it is today. This is not a conspiracy. This is not sensationalism. This is what the James Webb Space Telescope actually found. And the deeper you go into it, the more carefully you follow the data, the more the ground shifts beneath your feet. Because the universe, it turns out, does not care about our models. It never did. And James Webb is finally powerful enough to prove it. To understand what James Webb found, you first have to understand what James Webb is. Because this is not just another telescope. This is the most complex scientific instrument humanity has ever built. It took 30 years from the first design sketches to launch day. 30 years of engineering problems, budget overruns, delays, redesigns, and moments where the entire project nearly collapsed under its own ambition. It cost $10 billion. It required the expertise of thousands of scientists and engineers across multiple countries and agencies. It folded itself like an origami sculpture the size of a tennis court, just 5 meters wide. And on Christmas Day, 2021, it launched. There is something poetic about that. Christmas morning, a gift to humanity riding a rocket into the dark. For the next month, the world held its breath as Webb unfolded itself in space. Every deployment step had to work perfectly. There were 344 single-point failures, moments where one thing going wrong would have ended the mission entirely. All 344 succeeded. Webb traveled 1.5 million kilometers from Earth and settled into its final position, a gravitationally stable point called L2, where it would always have Earth and the Sun behind it, allowing its sun shield to keep its instruments cool to minus 233 degrees Celsius, near absolute zero, cold enough to detect the faintest infrared light, the ancient, stretched, cooling glow of the earliest galaxies. Because this is what Webb was designed to do. Hubble saw invisible light. Webb sees an infrared, light that has been stretched by the expansion of the universe itself into longer wavelengths that our eyes cannot detect. This means Webb can see further back in time than any instrument before it. It can look at the universe when it was not billions of years old, not hundreds of millions of years old, when it was just a few 100 million years old, a cosmic newborn, still raw, still forming its first structures. And when Webb looked at that earliest universe, when those first images came back and the scientists bent over their screens, what they found was not what anyone predicted, not even close. In the standard model of cosmology, the model that has guided our understanding for decades, galaxies form slowly. It is a bottom-up process. Gravity pulls small clumps of gas together. Those clumps form the first stars. Stars live and die. Their remnants accumulate. Over hundreds of millions, then billions of years, those accumulations merge and grow into the large, structured galaxies we see in the universe today. It is a slow, grinding, majestic process. Slow is the key word. A large, massive, fully formed galaxy, the kind with defined structure, with billions of mature stars, with organized rotation, should not be able to exist in the very early universe. There simply has not been enough time for gravity to do that much work. This is not a fringe idea. This is core cosmology. This is textbook. This is what every major cosmological model agreed upon for the better part of a century. Then Webb looked at the early universe, and it found massive galaxies. Not small, chaotic, proto-galactic clumps struggling to take shape. Massive, mature, structured galaxies containing hundreds of billions of stars, as many as the Milky Way contains today, existing at a time when the universe was only 500 to 700 million years old. In some cases, even earlier. One galaxy Webb detected, cataloged as JADES GS-Z-130, existed when the universe was just 320 million years old, less than 2.5% of its current age. And it was not a tiny, fragile infant galaxy taking its first uncertain steps. It was enormous. To put that in human terms, imagine meeting a fully grown adult who, according to their birth certificate, was born 4 months ago. That is the scale of the contradiction. The scientific community's response was not dismissal. Scientists do not dismiss data. The response was something more unsettling, a kind of controlled, professional alarm. Papers were published. Titles like Panic at the Discovery and A Problem with Galaxy Formation appeared in the scientific literature. Actual titles, because the researchers writing them understood what they were seeing. The timeline we had built for the universe, the carefully constructed chronology of cosmic evolution that took generations of astronomers to assemble, had a crack in it. A very large crack. And James Webb was not done. It was just getting started. Impossible galaxies were not the only thing Webb found. While one team was rewriting the history of the early universe, another team was doing something more intimate, more personal, more directly connected to the question that human beings have asked since the first night someone looked up at the stars and wondered, are we alone? Webb was designed with the ability to analyze the atmospheres of planets orbiting other stars, distant worlds, exoplanets, using a technique called transmission spectroscopy, measuring the specific wavelengths of starlight that filter through a planet's atmosphere as it passes in front of its star. Webb can identify the molecular fingerprints of the gases present: water vapor, carbon dioxide, methane, oxygen, the building blocks of life as we know it. And in the atmosphere of a planet called K218b, a world roughly 2.6 times the size of Earth, orbiting a cool red dwarf star 120 light-years away, Webb detected something that sent a jolt through the scientific community. Carbon dioxide, methane, and the possible signal of a molecule called dimethyl sulfide. On Earth, dimethyl sulfide is produced by only one known process: living organisms, specifically marine microbes, phytoplankton in our oceans. Now, and this must be said clearly, this is not confirmation of life. Webb's detection of dimethyl sulfide is a possible signal, a candidate. It needs to be verified with further observations, and there are non-biological processes that could, in theory, produce it. But here is what matters. For the first time in human history, a telescope detected a molecule in the atmosphere of a distant world that, on Earth, is associated exclusively with life. The scientists who announced this finding were careful, measured, appropriately cautious. But behind the careful language, behind the hedged phrasing of a peer-reviewed paper, was something that has never quite been said before in the history of science. We may have found a trace. Not proof, not certainty, but a trace. A whisper from a world 120 light-years away, carried on the light of a distant star, caught by a golden mirror floating silently in the cold of deep space. And it sounded like life. This alone, even as a possibility, rewrites what it means to be human in this universe. Because if life exists on K2-18b, then we are not rare. We are not a cosmic accident. We are a pattern, a recurring theme in a universe that finds a way to wake up and look at itself again and again, in different corners, in different forms, across unimaginable distances. But the deepest impossibility Webb revealed is not the galaxies. It is not the dimethyl sulfide. It is what all of these discoveries, taken together, are trying to tell us.
Science has a complicated relationship with the word impossible. Every generation of scientists has stood before something that seemed to violate the known rules of the universe, and every generation eventually has done one of two things. Either they found the error in their measurement, or they rewrote the rules. The impossible galaxies Webb detected are almost certainly real. The measurements have been repeated, cross-checked, confirmed by independent teams. The debate now is not whether they exist. The debate is what they mean. Some scientists believe they reveal a flaw in our understanding of dark matter, the invisible substance that provides the gravitational scaffolding for galaxy formation. If dark matter behaves differently in the early universe than our models predict, galaxies could form faster than we thought. Others believe the answer lies in the nature of the very first stars, the population 3 stars, those massive, brilliant pioneers of the early cosmos, and that they seeded the universe with structure far more efficiently than we modeled. Still others are asking a deeper question, a more unsettling one. What if the standard cosmological model itself needs revision? Not abandoned, not thrown away, but fundamentally updated in ways that will take a generation of physicists and astronomers to work out. This is not a crisis. This is science doing exactly what science is supposed to do. Webb is not breaking physics. It is stress testing our understanding of physics. And where the cracks appear, that is precisely where the next great discoveries will be made. Because here is the truth about impossible things. They are never truly impossible. They're just questions we have not answered yet. Every discovery Webb makes, every impossible galaxy, every atmospheric fingerprint, every ancient structure that defies our timeline is not a failure of human understanding. It is an invitation to go further, think harder, ask better questions, build better models, and eventually look back at what once seemed impossible and understand it so completely that it feels obvious. That is the arc of science. It has always been the arc of science. We thought the Earth was the center of the universe. Then we thought the Milky Way was the entire universe. Then we thought the universe was static and eternal. One by one, the impossible revealed itself as the next truth waiting to be understood. James Webb is giving us the next batch of impossibilities to wrestle with. And somewhere in those wrestling matches, in those late nights staring at data that does not fit, in those papers with titles that carry a hint of panic, in those quiet rooms where brilliant people ask each other, what if we have been wrong? The next revolution is already beginning. We live in an extraordinary moment. A moment when we have built an eye powerful enough to see to the edge of time, powerful enough to read the chemistry of distant worlds, powerful enough to find the cracks in our own understanding and begin carefully to look through them. James Webb did not just detect something impossible. It detected the universe being more extraordinary than we had the imagination to predict. And if history has taught us anything about the cosmos, it is always more. Always.